After we talk about the production function, we want to know how businesses would respond to changes in the costs of various inputs. Of course, specifically for coffee, olives, and wine. Now, farmers face cost increases from climate change. Some of that is from the greater uncertainty of weather. The date of last frost is important, the amount of rainfall, how many sunny days. There are various ways the farmers can ameliorate some of those, which we'll talk about later in more detail, but they're costly in various ways. If there's less rain, farmers can irrigate. If there's too much sun, can plant shade trees or put up cover. Farmers can use more fertilizer to boost yields. Then there are the choices of the businesses farther up the chain from the farm. Coffee roasters can choose to source beans from different areas. Wine vintners can make substitutions about where they get their grapes. Olive oil presses can get olives from other farms. We can divide cost into three broad categories: cost of materials, cost of labor, and cost of rent. For a coffee shop, cost of materials is the beans, the milks, sugar cups, machines for roasting and pouring, all that stuff. Labor costs for baristas and roasters, dishwashers, managers. Rent is one of their largest costs and the most variable. A coffee shop, say in or near Grand Central Terminal, has an enormous volume of customers every day. But the landlord is the one who gets the benefit of that, not the business. Economic rents are the value of a monopoly, and a location along a well-trafficked area is a monopoly enforced by legal means. Other private property, such as a patent, could give other monopoly rents. As we go back from the consumer, other businesses also pay rent costs, back to the farmer who grew the beans on a particular piece of land that was suitable for coffee and had to pay rent for that. Now, the basic economic theory about how businesses react to cost changes is summarized by the Hicks-Marshall rules of derived demand. The basic question when an input price changes, how elastic is the quantity of that input in firms' demand for that input? Again, for now we're thinking of coffee, olives, and grapes, but those principles apply to other inputs such as labor just as well. If there's a poor harvest and the price rises for beans, then some coffee shop, perhaps a big chain, has to make changes. One extreme case could be there's zero elasticity. The bean is so valuable that the business will just pay the increased cost. The opposite extreme could be there's infinite elasticity. The business sees the increased cost and zeroes out use of that. Most cases will be towards the middle, where the business makes some reduction in use. But we'd like to be able to assess where in the middle. The business use of the input will be more sensitive to price, more elastic, in cases where these conditions are met. First, if the price elasticity of the final product is higher. Some final products are very sensitive to price changes, others are not. If a hospital has to pay more for a particular drug, they can raise their prices. People in the ER are not particularly sensitive to cost. On the other hand, splurge items can be very sensitive to price. Next, to what degree is it technologically feasible to substitute other factors? If coffee beans from a wide swath of Central South America become more expensive, then beans from other countries can be substituted. And that will influence the taste. Or Robusta beans could be substituted for Arabica. They're lower quality, but in some cases, some amount of substitution could be nearly imperceptible. Related question is how elastic those replacement inputs are. If a business wants to double the amount of beans they buy from an island in Indonesia, say, how much would that price move? The final consideration is the cost share of the input. If the input makes up a rather small fraction of the price that consumers pay, then even substantial price changes may have pretty small impact. Things are never that simple, though. The supply chain can be very long, and that creates its own source of instability. The bullwhip effect was identified decades ago. It's the observation that as you get further away from the final consumer, there are larger and larger variations in orders. A typical supply chain might go from the initial producer to distributor to wholesaler to retailer to consumer. At each step, there are people who are managing inventory. They don't want too much inventory since they have to store it, and some product will go bad, but they also don't want to fall short. So they try to look in the future and figure out how much to order. Some of the bullwhip effect comes from psychological factor that people might become over optimistic. But a lot of it is just simple inventory behavior. For example, suppose a wine shop sells 1,000 bottles a month and has 4,000 bottles in inventory. So each month they buy 1,000 from their wholesaler, sell 1,000, they have the same 4,000 inventory. Turns over, we'll assume, at a steady rate. Now suddenly, suppose they see an increase in sales to 2,000 from 1,000, so their inventory drops down to just 3,000. How much do they order next month? Well, at least they want their usual 1,000, plus probably another 1,000 to make up for the diminished inventory. So that's at least double orders. But if they think they're going to be selling 2,000 a month going on in the future, then they might want to double their inventory as well. So they could order 3,000 or 4,000. So an increase in demand of 1,000 leads to 2,000 or 3,000 increase in orders. Their wholesaler might see not a doubling, but a tripling of their usual sales. And then that goes to the next step up the value chain with an even larger order. And of course, that goes as sales decrease as well. If the wine shop sells only 500, then that means they have an extra 500 bottles unsold in inventory. They might skip deliveries next month. So again, a change in final demand of 500 could mean a change of 1,000 in orders from wholesalers. And again, that goes up the chain too. So by the time it gets to the farmer, they're seeing huge swings. Bottom line, it's tough to be a farmer. They see huge, well, for a lot of reasons, including the bullwhip effect, they see big changes in demand for their products.